In the last video, we were looking at a very simple e-commerce application, and we saw that if we start to introduce this new service down here that relies upon data from these other services, life starts to get really challenging really quickly if we are going to follow that pattern of database per service, because service D cannot reach directly over to this database, this one, or this one. So in this video, we're going to take a look at two very general strategies that we can use to solve this problem. These two general strategies that we're going to use are really talking about how we communicate between different services. There are two general strategies referred to as synchronous or sync and asynchronous or async. I want you to understand right away that in the microservices world, these terms do not mean what they mean in the JavaScript world. So JavaScript has its own definition of sync and async. That is not the same thing as sync and async in microservices. Very different terms. So let's first begin by taking a look at the definition of a synchronous communication style. Okay, so in this synchronous world, if we are going to communicate between different services using this pattern, we're going to have one service communicate with another directly using requests. This doesn't necessarily have to be an HTTP request or a request that exchanges JSON. It is just some kind of direct request, whatever its form is. A direct request from service A over to service B to fetch some information. Rather than taking a look at the definition of async, let's first take a look at an example of synchronous communication right away. All right, so we're going to apply this idea of synchronous communication to the example that we were looking at just a moment ago. So once again, we are imagining this e-commerce application where we've got users, products, and orders down here in service C. So if we were going to use synchronous communication, we can imagine that a request might come into service D, and it might say, show me all the products that have been ordered by the user with ID number 1. The first thing that service D might do is make a direct request over to service A. Again, that might be a plain HTTP request. It might exchange JSON. Whatever its form is, it is a direct request from D over to A. So service D would then check to make sure that maybe that user exists. It would then get a response back. And if that user exists, it might then make a follow-up request over to service C and find all the orders that have been created for this user. It would get back a response and then finally make a request over to service B and say, give me details about these particular products. So after making those 3 different requests, service D would then have all the information it needs to respond to the overall request. At no point in time did service D reach directly into any of these databases over here. So we have not violated any big rules around our database per service pattern. Now, there's some definite upsides and downsides to this approach. So let's take a look at those right away. The upsides to this are that using synchronous communication is pretty easy to understand. I think that by pretty much just looking at this diagram, you've probably got a reasonable idea of how this stuff works. We create a service. It makes requests to other services to get data. That's it. So conceptually, not the worst thing. The other nice thing about this approach is that service D is not going to need a database. So that's service D right here. We won't have to provision, maintain, pay for a database. Service D relies upon data coming from these other services that have their own databases, so no database required. But like I said, there are some really big downsides to this approach as well. The downsides are, first off, it introduces a dependency between service D and those other 3. That means that if any of these services go down for any reason, like let's say service A, if that goes down right there, now all of a sudden, service D is not going to work correctly either. So service D is going to fail entirely as well. That means that we might lose the functionality of big pieces of our application at some point in time if some key critical service starts to go down. The next big issue is that if any of these inter-service requests fail, the overall request is going to fail as well. So very similar to what we just said about service A failing, if for some reason this request right here fails, well, now we don't know if that user exists, so chances are we would throw an error and respond to the request and say, sorry, but an error occurred, can't help you. The next big downside is that this entire request is only as fast as the slowest request. So let's imagine that this request over to the user service right here takes, how about 10 milliseconds? And then maybe the next one down here to get all the products ordered by that person takes another 10 milliseconds. And then finally, service B right here, maybe for some crazy reason, that takes 20 seconds. So 20 seconds to make that final request right there. So that means that overall, we're going to have 20 and 20 milliseconds to complete the overall request. So we're only ever going to be as fast as the slowest request. And then finally, this one's a little bit harder to understand, but this can introduce a web of dependencies that starts to really spiral out of control. So the key thing to keep in mind around microservices, different diagram right here really quickly, is that we don't necessarily know what some other service is doing internally. So if you and I are trying to develop service D, we might know that we need to make a request to A, B, and C, but we might not know what those things are doing internally. And it turns out that service A internally, to work correctly, might need to make its own request over to service Q. And service Q in turn might need to make its own request to Z and X down here. And so you can really start to imagine that to service any given request, like the one coming from service D right here, there might be a huge multitude of requests going on behind the scenes. Dozens, if not hundreds of requests just to service this one simple original request that came into D. And once again, if any of these things go wrong, like if that fails right there, or if that fails right there, well, all of a sudden, the entire overall request fails as well. And once again, we're only as fast as the slowest operation. So in practice, sync communication, well, there's some definite upsides, but there are some gigantic operational downsides as well. Okay, so we've now got a pretty reasonable understanding of synchronous communication, and so that just leaves async. So let's take a pause right here. Async is a little bit more confusing. We'll take a look at how that works in just a moment.